Hello everyone and welcome back to PreCalculus Redone. This is the third episode in the series where I do some actual absolute value equations using the distance approach. Because this video is mostly practice problems, I encourage you guys to pause the video each time a new problem comes up and attempt it yourself. If you're unable to solve it or get stuck, just simply resume the video. If you finish the problem, unpause and follow my steps to see if you showed your work correctly, and then see if you got the right answer. First up, let's start off with a slightly easy one. 3 times the absolute value of 4x minus 8 plus 5 is equal to 35. The first thing I want you to notice is that there are no variables outside of the absolute value. This means we can use the distance approach. But first, we need our equation to be in the correct form. The one we established in the last video is x minus h is equal to c. I immediately notice 3 issues. This 3, this 4, and this 5. They all prevent us from being able to use the distance approach because of our form x minus h in absolute values is equal to c. So I'm going to do some algebraic manipulation to isolate the absolute value. We'll deal with the 4 at the end. So what I'm going to do is, I'm going to write out each step, and I'm not going to show the minus 5 to each side, but by showing each step, you should be able to tell if you're looking over my work. So when we subtract 5 from both sides, we get 3 times the absolute value of 4x minus 8 is equal to 30. Then we divide both sides by 3, and we get the absolute value of 4x minus 8 is equal to 10. Now it's time to deal with our 4. To deal with our 4, let's factor out 4 from the inside of the absolute value. So you get 4 times x minus 2, the quantity, is equal to 10. Now we can split it into its own absolute value. The absolute value of 4 times the absolute value of x minus 2. Now we can get rid of the absolute value bars around the 4. Because 4 is positive, and we can divide both sides by 4. If we simplify the fraction that will be on the right side, we get 5 over 2. Now we're in the form x minus h in the absolute value is equal to c, so we can use the distance approach. I'm going to draw a number line for this example just to remind you guys. I won't do that for the future examples though. Our center point h is positive 2. Then we go 2 plus our distance c, 5 halves, and we subtract 2 minus 5 halves. So our solutions are x is 2 minus 5 halves and 2 plus 5 halves. When you add the fractions, you get x is equal to negative a half and 9 halves. And that's your answer. I highly encourage you to plug in the initial equation as well as your solutions into Desmos and visualize each of these problems. But that's for you to do. In this video, I'm just going to solve these. For our next problem, we're going to do 2/3 times the absolute value of 3 minus 2x, then minus 3 on the outside, is equal to 4. I'm noticing 4 issues with this. This minus 3, the 2/3, this 2, and then this negative is a separate issue. We have a negative x. So we'll deal with these one at a time. First, the negative 3. We're going to add 3 to both sides to get rid of that. To get rid of the 2/3, I'm going to multiply 3 halves to both sides. That way, these 3's cancel and these 2's cancel. So we're left with 3 minus 2x is equal to 21 over 2. Now let's deal with the 2 and the negative at the same time. I'm going to factor out a negative 2. What we get is x minus 3 halves. If you redistribute the negative 2 to the negative 3 halves, we get positive 3. So that means we did it correctly. And we rewrite the rest of the equation. Now when we split it into the separate absolute value, we get the absolute value of negative 2 times the absolute value of x minus 3 halves is equal to 21 over 2. Now what's nice is the absolute value deals with the negative for us. It forces it positive. Now all we have to do is divide by 2. Or the way I'm going to do it, I'm going to multiply by 1/2. They're the same thing. It just looks a little different. Now we're in the form to use the distance approach. So x is equal to 3 halves minus 21 over 4 and 3 halves plus 21 over 4. When you combine the fractions, you get x equals negative 15 over 4 and 27 over 4. That's your answer. For our last example, it's a little bit of a special case that we kind of addressed in the last video. 4 halves times the absolute value of x plus 7 plus 12 is equal to 4. As usual, let's isolate the absolute value to get it into standard form. So we subtract 12 from both sides. We get 4/5 times x plus 7 is equal to negative 8. And you might already see the issue. Is this negative? So even when we multiply both sides by 5/4, we get the absolute value of x plus 7 is equal to negative 10. And the issue still stands. That's a negative number. Absolute value always returns a positive number. So there's no way on planet Earth that it could be negative, let alone negative 10. So on my math tests, what I like to do in this case is I write never true. This is more for me, and this should not be your final words, because after this, you write no solution. So if the absolute value can never be negative, which is the case, then that means this equation is never true. And if the equation is never true, there's no x value that could make it true, which means no solution. So now I write no solution. You could also write an empty set. That works just fine. That's all the problems I have for this video. Stay tuned for the next video, where we rewrite absolute values as a piecewise function. Bye guys.